All right, so today we are diving into quantum computing, and you have given us some really fascinating material to work with. You've clearly been digging into Microsoft's work in this area. And rather than just giving you a basic rundown, we're going to unpack all of this. So get ready for some of those aha moments, like those times when you're reading something and suddenly it all clicks. And more importantly, by the end, we're going to know why all of this matters to you. So quantum computing, I mean, it seems like it's everywhere these days. But honestly, it often feels more like a buzzword than anything else. So let's cut through the hype. What's really going on here? And what is Microsoft's grand plan in all of this? Well, one thing that really struck me from the materials you gave us is this emphasis on reliable quantum computing. Like you're building this whole platform called Azure Quantum. And it's all about making quantum computing something we can actually depend on. It's almost as if they're saying, okay, sure, quantum's really cool in theory, but can we actually use it to solve real problems?
Yeah, and the articles you sent really point to why that's such a big deal. Because right now, a lot of these quantum computers are what they call noisy. Basically, they're incredibly sensitive. Even the smallest change in temperature or the tiniest vibration can totally mess up their calculations.
It's like trying to run a company's payroll on a calculator that keeps changing the numbers randomly.
Yeah.
Definitely not ideal.
Exactly. And that's where these things called logical qubits come in. Think of them like taking a whole bunch of those wonky calculators and finding a way to link them together. So suddenly, even though each individual calculator is kind of messed up together, they start giving you the right answers consistently.
So Microsoft is saying they're making some real progress with these more stable logical qubits. But why is this such a big deal for them? Why are they so focused on this idea of reliable quantum computing?
It all comes down to scalability and real-world impact. Building a super powerful but super finicky quantum computer in a lab is one thing, but getting it to actually work with real-world data reliably and at a large scale, that's a whole other ballgame.
Yeah.
Without that reliability, it's like having a Ferrari that can only drive in circles. Impressive, sure, but not very practical.
So how do they actually make these things more reliable?
Well, that's where this whole area of error correction comes in, and it is a huge challenge. You're basically trying to outsmart the quantum weirdness to make sure these computers are not just powerful, but predictable as well. And Microsoft is putting a lot of resources into making that happen. They want trustworthiness alongside that raw computational power.
So they want their quantum computers to be the reliable workhorse, not just the flashy sports car. But it seems like Microsoft isn't trying to crack this quantum code all alone, right? The material you sent mentioned these two big partnerships,
Right.
Quantinuum and Atom Computing. So it sounds like teamwork is a big part of their strategy here.
Yeah, absolutely. It's like they've realized that in such a cutting edge field, it makes a lot more sense to join forces with others who are pushing the boundaries.
So let's dive into these partnerships a bit. First up, we've got Quantinuum. Now, honestly, when I first heard about their ion trap technology, it kind of sounded like something out of Star Trek,
It does, doesn't it?
but like way cooler, obviously. And from what I understand, they've managed to do something really remarkable. They've entangled 12 logical qubits, and they're working with incredible precision. Now, no, we don't want to get too lost in the weeds here, but this whole entanglement thing, that's kind of a big deal, right?
Oh, it's huge. Basically, it means those qubits aren't just doing their own thing. They're linked together in a way that lets them act as one super powerful unit.
So instead of a bunch of individual singers, you've got a whole choir hitting those perfect harmonies.
Exactly. And that's where you get this exponential increase in computational power.
And then on the other side, we have atom computing. They're taking a different approach with this neutral atom technology. And they're not shying away from big goals either. They're talking about building the most powerful quantum computer the world has ever seen,
Yeah, they're really swinging for the fences.
which I kind of love.
Yeah.
And it seems like all of this feeds into Microsoft's focus on scalability.
Absolutely. It's not just about solving today's problems. It's about building for a future where we're tackling challenges that require a whole new level of computational power.
So we've got these quantum powerhouses in the making. But what good is all that power if we don't know how to actually use it right? And that's where this idea of hybrid applications comes in, which honestly, when I first saw it, I thought maybe it was talking about a car or something, like a car that runs on quantum fuel.
Well, I'm sure someone somewhere is working on that. But hybrid applications in this context are even cooler.
Oh, yeah.
Think of it this way. We're talking about combining the best of quantum computing with the strengths of our good old-fashioned classical computers, and even throwing AI into the mix.
So it's like having this whole team of specialists with different skills working together to solve a problem.
Exactly. It's about using the right tool for the job and making sure they all work together seamlessly.
And the articles you sent had that perfect example of this, the one about simulating a complex chemical reaction. They used a supercomputer for the initial calculations, then AI, to analyze the data and make predictions. And then they brought in the logical qubit computation for the really, really complex parts.
It's like a symphony of computational power.
Right. It's not about replacing our existing technology. It's about finding those areas where quantum can really shine and then figuring out how to integrate it into a larger system.
Exactly. And that's what makes this whole field so incredibly exciting. The real potential isn't just about quantum computers in isolation. It's about how they fit into a larger ecosystem of technologies to help us solve problems that seemed impossible before.
So we've covered a lot of ground here today. We've talked about the incredible potential of quantum computing, the challenges of reliability, Microsoft's strategic partnerships, and this mind-blowing concept of hybrid applications. But you've been digging into all of this, so let's bring it back around. What's the key takeaway for you? Why should you care about all of this?
Well, for one thing, it's clear that Microsoft is all in on quantum computing. They're not just dipping their toes in the water, they are diving in headfirst. With this focus on reliability partnerships and building a platform for these hybrid applications.
And that's huge. They're essentially positioning themselves to be the go-to platform for anyone who wants to harness the power of quantum, which, let's be honest, could revolutionize pretty much every industry out there. Yeah, exactly. From medicine to material science to AI, the possibilities are pretty much endless. But there's one more thing I wanted to touch on before we wrap up. Something from the articles that really caught my eye. Remember how they mentioned Microsoft's research into something called topological qubits? Apparently, these could be even faster and more scalable than anything we've seen so far. It's like they've got this secret weapon up their sleeve. So what if these partnerships are just the tip of the iceberg? What if Microsoft's real breakthrough is still yet to come? Definitely something to think about. And on that note, we'll wrap up our deep dive into the world of quantum computing and Microsoft's ambitious plans. Until next time, keep those brainwaves buzzing.